All right, folks, let's do some more interesting edit algorithms. Here, I want to generate some better edits, right? So when possible, I'd like to substitute rather than just adding and delete. So to that end, we've given you a function to start with, just as sort of a hint. Naive subedit will, as much as it can, generate substitute edits. So how does it work? It walks down a source strand and a target strand, looking at them both, and it says, okay, well, whatever we see in the target strand, just substitute for that, and then keep going. Now, if one of them runs out, we'll use add edit if we run out of the source strand, or delete edit if we run out of the target strand, to sort of finish up to make sure we get the rest of the strands involved. So this is a function that will do better than delete add edit. It's still not great. We've called it naive because it's doing something a little bit silly in one of its cases. To start with, let's just sort of see what we might expect. Compute naive subedit on DNA source to DNA target 1. Okay, so this is generating substitute TCAT and then added an empty list, which, just to give you a hint, I expect this one to be empty list, though it's not defined in my file, so it's not telling us. And then we can see for DNA target 2, it'll substitute CAT in for the GCNA, and then we'll have whatever the delete edit is for what's left of this single edit T here. Right? Not defined, but I expect it to be a single delete for T. Okay, so that's naive subedit. Produces some edits that use substitution. So okay, great. At least now we're finally using our sort of full repertoire of edits. Almost. But we have two exercises for you. First, why is this naive? Give me a source and target strand where it gives a high cost when it could give a really low cost. And then explain why. And then define a function that is maybe not so naive, shall we say, a little more experienced. So this function subedit should avoid the problem that you describe here, right? There's some format, there's some source and target pair that you could get where naive subedit just really messes it up, right? It just like gives you a very high cost, nowhere near minimal edit. And we'd like you to do better, right? There's a situation where you could generate something much lower cost that naive subedit is just leaving on the table. So define a function subedit that handles that one properly. Okay, play around with it for a bit. I'm happy to give some hints in Zulip, but I really want you to think about it for a while. Um, I think DNA source and DNA target 1 are a great place to start looking. And just sort of think about what our different edits are, and what we might generate instead. Um, to do a good job there. Okay, after this we have just one more video where I'm going to talk about the Levenstein algorithm and walk you through how you're going to need to implement it, and maybe sum up sort of where we're at and make sure that everyone's on the same page about what we've done so far. This has been a sort of long, circuitous tour to get to the explanation of our algorithm, but I hope you trust that it'll be the right way that gives you the most understanding. All right, I'll talk to you soon.